Welcome to all for today's session. In today's session, we are going to discuss about the main topic called aerodynamic center in the subject aerodynamics. Actually, aerodynamic center is a crucial concept in aerodynamics, particularly in the design and analysis of airfoils, wings, and anti-aircraft. Actually, it is a point where certain aerodynamic properties are simplified and making it easier to analyze and predict the behavior of aircraft. Let's come to the point for the definition of an aerodynamic center. The aerodynamic center is the point along the chord line of an airfoil or wing or entire aircraft where the pitching moment, the moment about the aerodynamic center remains constant regardless of the angle of attack. Once again, I'm repeating that the aerodynamic center is the point along the chord line of an airfoil, wing, or entire aircraft where the pitching moment or the moment above the aerodynamic center remains constant regardless of the angle of attack. This property makes the aircraft a convenient reference point, that the aerodynamic center a convenient reference point. Actually, this aerodynamic center is a reference point for stability and control calculations because it simplifies the analysis of moments due to the aerodynamic forces. Next, we are going to discuss the key characteristics of the aerodynamic center. First one is called constant pitching moment. The second one is relation to pressure distribution and location for subsonic airfoils and location for supersonic airfoils. So those things we are coming to concentrate here. For constant pitching moment, here at the aerodynamic center, the aerodynamic moment, that means moment about the aerodynamic center, does not vary with the changes in the angle of attack. Even if it is alpha equal to 0, then alpha equal to 5 degree, alpha equal to 10 degree, if the angle of attack goes on changing, but this aerodynamic center does not change. This is because the shift in the lift distribution as the angle of attack changes is balanced, which causes the moment above the aerodynamic center to remain constant. Next is relation to pressure distribution. The aerodynamic center is dependent on the pressure distribution around the airfoil. The aerodynamic center is dependent on the pressure distribution around the airfoil. As the flow over the airfoil changes, the forces acting on the airfoil shift, but the aerodynamic center remains fixed for a given airfoil in subsonic flow. Next is the location for subsonic airfoils. Here are for symmetric and cambered airfoils in subsonic flow, the aerodynamic center is typically located near the quarter chord point. That means 25% of the chord length, other is called C by 4 as a notation. From the leading edge, it is represented. Okay. For subsonic airfoil, that means for any symmetric as well as cambered airfoil, you can take as in subsonic flow, the aerodynamic center typically located near the quarter chord point. This is an approximation that holds true incompressible. It holds true for incompressible flows only, not for a compressible flow. It can change. Location for supersonic flows, supersonic airfoils. For subsonic flow, we told it is quarter chord point. But for supersonic flow, the aerodynamic center shifts closer to the mid-chord point, around 50% of the chord length. This is due to the influence of shock waves and the changes in the pressure distribution in high-speed flows. Next, independent of angle of attack. Unlike the center of pressure, which moves with the changes of the angle of attack, the aerodynamic center remains stationary for a specific aerofoil or wing in a given region. And how can we do the representation? There is a mathematical representation. For aerodynamic center, the mathematical representation, the pitching moment about the aerodynamic center can be expressed half rho v squared AC into Cm about aerodynamic center, where half rho v squared is the dynamic pressure, S represents the reference area, and C represents the chord length, as well as the M represents the Cm represents the moment coefficient of moment about the aerodynamic center. How to compare with other points? That means with respect to center of pressure, how can we compare? As well as center of gravity, how can we compare? Those things we have to discuss here. The center of pressure, first, what is center of pressure? Actually, center of pressure is the point where the total aerodynamic force acts. Okay, it's like a center of gravity. Okay, the aerodynamic force means lift and drag, we have to concentrate. Unlike the aerodynamic center, the center of pressure moves with changes in the angle of attack. Okay, so aerodynamic center does not change with respect to the angle of attack, but the center of pressure changes with respect to the angle of attack changes. At low angle of attack, the center of pressure is near the leading edge. At low angle of attack, the center of pressure is near the leading edge. At a high angle of attack, it moves aft at the trailing edge actually. Center of gravity is the point where the aircraft mass is concentrated. Stability depends on the relationship between the center of gravity and the aerodynamic center. And what are the applications related with this aerodynamic center? One is aircraft stability. Then wing design, as well as while analyzing the analysis for the simplification. Under these conditions, the aerodynamic center plays a very crucial role. So, the aerodynamic center plays a crucial role in determining the static stability of an aircraft. For an aircraft to be stable, the center of gravity must be ahead of the aerodynamic center. This ensures a restoring moment is created when the aircraft pitches. With respect to the in concentration with the wing design, the wing mounted engines, control surfaces, and payloads must be placed considering the aerodynamic center to maintain balance and stability. Simplification analysis here, the using the aerodynamic center simplifies the calculation of moments, such as it eliminates the need for to account for varying the pitching moment due to the angle of attack. If the chord length for a typical aircraft, if the chord length of the wing is 10 meter, the aerodynamic center in subsonic flow will be approximately 22.5 meters from the leading edge. That means quarter chord point, as we said earlier. During flight condition, even as the angle of attack increases to generate more lift, the pitching moment about this aerodynamic center remains constant. And we can move on to other things. That means aerodynamic center, we have concentrating here. With respect to angle of attack, it does not changes. Okay, just wait. So in the given diagram, here look on the diagram. So the moment as well as aerodynamic force, the point is given. That point is called aerodynamic center. At low angle of attack, it will be at a quarter chord point, but at a high angle of attack, it is given. It's moving towards off. Okay. But the moment above the aerodynamic center is constant with the angle, the aerodynamic center does not move with the angle. As an object moves through a fluid, the velocity of the fluid varies around the surface of the object. The variation of velocity produces variation of pressure on the surface of the object. Integrating the pressure times the surface area around the body determines the aerodynamic force of the object. We can consider this force to act through the average location of the pressure on the surface of the object. We call the average location of the pressure variation the center of pressure in the same way that we call the average location of the weight of an object the center of gravity. In general, the pressure distribution around the object also imparts a torque or moment on the object. If a flying airfoil is not constrained in some way, it will flip as it moves through the air. So that's all about aerodynamic center in this class. Once again, I'm just concluding. For symmetric airfoils, the aerodynamic moment about the aerodynamic center is zero for all angles of attack. For all angles of attack, the aerodynamic moment about the aerodynamic center is zero. With the camber, the moment is non-zero. It means normally negative for positive camber and a constant for thin airfoils. With the camber, an angle of attack can be determined for which the airfoil produces no lift but the moment is still present. For rectangular wings, the wing aerodynamic center is same as the airfoil aerodynamic center. But for wings with some other platform called a triangular or a trapezoidal or compound platform, we have to find the mean aerodynamic center, which is the average for all whole wing. Okay, so that's all for the today's session. We will conclude now. We will see once again in the next class. Thank you, 100% here. Thank you.